All right, yesterday we did this, so you need to go on Teams, and there is a 10-question assignment over yesterday's notes, so be sure you're doing that. All right, so we are on page 43 of our journal, and we're going to actually be making this table. For some reason, it's taken a while to upload, to show. So we're going to make that table in our journals. We are going to be using this table a lot. We're going to be practicing making this table, actually, because it's very important. So I am on page 50 of my journal because that's where we left off. So on page 50, and I am on the left side, and I'm going to turn my journal sideways so that I can make this table. All right, so I'm going to draw a box. It's going to fill up pretty much the whole page. Okay. And so here's our halfway mark. We want to go above the halfway mark. And I'll put another line. And then I'm going to go somewhere down the middle. So I've made 4 boxes, but the 2 bottom boxes are bigger. All right, so our first one we're going to look at is translations. Translations. So translations are the ones that slide. So I'll put a note here that it is a slide. And that's when I'm moving things left and right, up and down. So we have 2 different movements. We have the up and down. And this up and down. And we're going to look at how does that up and down affect my X and Y coordinates. Okay. My up and down is going to affect my Y. So I want you to literally do your pencil up and down. That is my y-axis if I was looking at a coordinate grid. So it's going to affect my y. So my x will stay the same, but my y, I'm going to either add or subtract to that y. Whatever my up and down motion, so if it says to slide it 10 up, I would add 10 to my y value. The other way we have motion is left and right. So when it says translate 4 to the right, and how does that affect my x and y? Well, left and right is my x-axis, so it's going to affect my x value by adding or subtracting to that x. Okay? Now, we are going to practice putting all of these into motion, but let's think about what that's saying. If it says to go up 2 and to the left 3, so up 2 would add 2 to my y value, and to the left 3, left is a subtraction, I would subtract 3 from my x value. Okay? This is looking at translations, reflections, rotations, dilations without having to graph them. It's called the algebraic. All right, our next one is our reflection, when we flip something over. So I'm going to draw an arrow, and I'm going to say flip. So if it goes over the x-axis, how's that going to affect? So if it says reflect over the x-axis, how is that going to change my x and y coordinates? Okay. My x is actually going to stay the same. I flipped over the x, my x stays the same. And my y is going to become the same number, but the opposite version. So, for instance, if it is 3, 2, it's now going to be 3, negative 2. All right? If I'm going over the y-axis, some of you might already be able to guess. This time my y will stay the same, but my x will be its opposite. So if it is 7, 4, when it is flipped over the y-axis, it's going to be negative 7, 4. So the reverse of this is that this x is a negative 2. What is the opposite of negative 2? Positive 2. So then it would be 2. And we're going to practice doing this. That's what we're doing the rest of today, and that's what we're doing tomorrow. All right, we're going to skip this bottom left because it's actually the hardest one. And we're going to go to this box, and we're going to do dilations in this box. And we're going to put that our k is our scale factor. And what does that do to our x and y? We multiply our x and our y both by that k. That's what we looked at yesterday. So a couple of notes about this is that it is multiplication. We are going to be multiplying. Our second note is that enlarge means that it's going to get big, which means my k is greater than 1. We also looked at that yesterday. And then our third rule for dilations is that when we reduce, that means it's getting small. And our k is going to be between 0 and 1. This is one of our fractions. All right, so let's just review that really quickly. So translation, when it's a slide, if it says move 5 to the right, my right will affect my x. So I'm going to add 5 to my x. When we're looking at reflections, whatever axis you flip over, that axis stays the same, that coordinate stays the same, and the other one becomes its opposite. In dilations, we looked at pretty big yesterday without even graphing some of them, and we multiply our scale factor times x and y. Those three aren't too hard with practice, but our rotation one is pretty challenging. So I'm going to show you a trick to the rotations. So we have two different kind of rotations. So down the middle, I'm going to do a squiggly line. On the left, we're going to look at clockwise. What happens when things are going clockwise? So I'm going to put myself a little note that clockwise is going this direction. It's going the direction of a clock. Okay. And we have different rotations. We have a 90-degree rotation. We have a 180-degree rotation. We have a 270, which is 390 degrees. And then we have a 360, which puts it right back to where it was. 4 different kind of rotations that we're looking at. So we're going to start with x, y. And what we're going to do is we're going to start with our x. And since clockwise goes to the right, we're going to slide this to the right. Okay. I'm going to move my 90 degrees just a little bit because this is going to be our 90 degrees. So when I slide that to the right, I flip it. So slide it and flip. Keep this one. So what happens is if my coordinate is 3, 2, for a 90-degree angle, it would be 2 because the 2 stay the same, and the 3 would become a negative. So if it is a 90 degrees clockwise, the new coordinate, if it was 3, 2, is now going to be 2, negative 3. To get 180, we slide this one, and it becomes its slide and flip, and keep this one. So 180 switches my x and y and flips them. So if the coordinate was 3, 2, it is now negative 3, negative 2. We're going to take our left coordinate, slide it, and flip it. And we keep this one. Slide, flip, keep. So if my coordinate was 3, 2, it is now negative 2, 3. The x stays positive, the y goes to its opposite. And we start here, we slide it, flip it, and bring this one down. Now we should start right back where we started, because a 360-degree turn has things facing the same direction they were before. So for instance, here's my triangle. So a 90-degree turn would look like this. A 180 would put it upside down. A 270, and then a 360 would put it right back where it belongs. So counterclockwise is the same process. Counterclockwise, except for this time, I rotate the left, because that's counterclockwise. So I'm going to start with XY. So this time I'm going to start this side, because I want to slide it that way. So I'm going to slide and flip. Start here, I'm going to slide and flip, and then bring this one down. Notice my two 180s are the same, because a 180-degree turn, no matter which direction it goes. So if it goes this direction, it looks like that. But if it goes this direction, it looks like that. So no matter what, 180 is going to be the same. So come back, slide, flip, and keep the first one. Slide, flip. All right, slide, flip. Sorry. Okay, if you can memorize this, it's going to help a lot, because rotations are kind of difficult. They're a little easier to do algebraically if you're good at memorizing things. I will tell you this now, on Friday's test, this chart will be on there blank. You're going to have to know these. All right? So I have attached some blank one of these, because in class today, that's what students are going to do. They're going to practice making these, and they're going to do it again tomorrow. They're going to practice making it, and they're going to work on learning to make it without looking at this. Okay? So I've attached some of them. If you want, if you can print them out. If not, you need to be able to do a box somehow of doing it. All right, so let's look at some practice problems. This is when it comes tricky, because we do have pictures, and I know that it's not always easy for y'all to do it when it has pictures. All right, so we have a rotation for number 1. All right, so I'm going to, let's do this. So this is going to go on the right side of the page. So if it says that I have a rotation 90 degrees counterclockwise, and my points are J, L, and Z. Let's see, J is -5, -2, and L is 0, -3, and Z is -4, 0. So rotation counterclockwise. So you can go to your table, but what I'm going to do is I'm going to practice making my table here. So counterclockwise is going to go this direction. So I'm going to start off with X and Y. So since I'm going this direction, I need to slide this direction. So slide and flip. Keep the X. Slide, flip, keep the Y. Slide, flip, keep that -X. And slide and flip and keep the Y. So I know that I'm finished when I'm back where I started. So this is my 90, my 180, my 270, 360. So my 90 degrees is going to be right here. So what I'm going to do is I'm going to take that y value, which is negative 2, and it's going to become its opposite. So for j prime, my 2 is going to move to over here, and it's going to become a positive 2. And my x slides to the other side and keeps. Look at L prime. So my y value is now going to be first. So my y value was negative 3, and it's going to be its opposite. So the opposite of negative 3 is positive 3, and my x is going to stay the same. And then my z prime, let's see, my my y is going to move to my x position and become its opposite. 0 doesn't have an opposite. It's the only one that's the same. And my x is going to stay the same. So this figure, rotated 90 degrees counterclockwise, is going to be these coordinates. All right? That's number 1. Let's look at number 2. Number 2 tells us that we have a translation that is 4 to the right and 1 down. 4 to the right and 1 down. So looking back at my translation rules, a translation rule says that for up and down, I'm going to add to the y. It's going to become x, y plus or minus the a. And for my left and right, because that's the x-axis, I'm going to add or subtract to my x. So to the right, 4 is going to be right here, and down 1 is going to be for my y. So let's look at my coordinates. So I have an f, I have a g, I have a y. That f coordinate is negative 5, 4. That g coordinate is negative 4, 2. And my y coordinate is negative 5, 1. So let's look. So if I'm going 4 to the right, that is a positive. And this was a down, and this was to the right. That's a positive. So I'm going to add 4 to my x values. So I'm going to come to each of my x values, and I'm going to add 4. Negative 5 plus 4 is negative 1. Negative 4 plus 4 is 0. Negative 5 plus 4 is negative 1. Down is a negative concept. So I'm going to subtract 1 from my y values. So 4 minus 1 is 3. 2 minus 1 is 1. 1 minus 1 is 0. Let's look at another one. We're going to skip to number 4. Number 4 is a reflection over the x-axis. Reflection over the x-axis. So going back and looking at my chart, x-axis means that it's going to become x negative y. My x stays the same, my y flips. So I have 4 coordinates this time. C, J, K, M. C is negative 3, 1. J is 0, 1. K is negative 1, negative 4. And M is negative 4, negative 2. Okay, so my C prime, J prime, K prime, and M prime. So my x's get to stay the same, so you can go down and do all your x's. None of them changed. They all get to stay the same. But my y value is going to become its opposite. The opposite of 1 is negative 1. The opposite of 1 is negative 1. The opposite of negative 4 is 4. The opposite of negative 2 is 2. Okay. let's look at writing some rules. So this is going to be a little difficult. So we're going to actually work on writing this rule. So we're going to label this as number 5. So I need to determine what kind of transformation is this. Is it translation, reflection, rotation, dilation? Well, I can see it's not dilation because it didn't get bigger or smaller. I can see that it didn't turn, so it's on a rotation. It didn't flip, so it's a translation. So it is a translation. For tomorrow's homework, you're going to have to tell me Thursday. Homework, you're going to have to tell me what kind of transformation it is. What's happening here? So here's my original. I'm going to shade it in so I can see it. And it's going to the right one. And that's it. It didn't move up and down at all. It just went to the right one. So looking at my transformations, I went from X, Y. So to the right is affecting my X because right and left affects my X because it's my X-axis. And to the right is a plus 1. So I am now doing X plus 1, and my Y stayed the same. It went to the right one, and that is on my X-axis, so I'm adding 1 to my X values. All right, let's look at number 6. Well, let's look. Is this a translation, a reflection, rotation, or dilation? Well, it's not dilation. The size stayed the same. Did it turn any? Nope, it didn't turn. Did it flip, though? And yes, it did flip. So it is a reflection. We're not going to go any further than that because this is actually not over an axis. Okay, but next step would be to determine, did it flip over an X or Y axis? It actually flipped over this right here, which is not either of them. But I wanted you to see, being able to identify what kind of transformation it is. If it had been over the X-axis, it would have changed my coordinate from XY to X negative Y. All right? We're going to practice more of these tomorrow. That's what we're spending the whole day doing tomorrow. Again, I encourage you to practice drawing this grid. I'm giving my in-class students 4 of them to practice, and then sending some home with them to practice. Because if you can get this down, this is a lot easier, obviously, because you're not going to be able to look back at this on the test. You're going to have to be able to do this in person, be able to draw this. I will be sending out directions on Friday's test. Friday's test has to be taken over a Zoom. So be prepared that you're going to have to do it over a Zoom, either in the form of I'm going to need to be able to see you. So if you don't have a camera, then we need to talk about downloading it on your phone or something. But be prepared because Friday's test will be taken over a Zoom call. All right. If you have any questions, please send them my direction.